Welcome back to some more EQAO preparation. We're going to take a look at the y equals mx plus b form of lines, which is just such a super important topic for us in grade 9, and one that it's easy to forget about. So it's good to get us back in some review. So get the copy of this review out for yourself so that you can follow along, and I'll talk through the various problems here and how you can demonstrate these skills. So the first question asks, if you have a line with a slope of 2 and a y-intercept of 3, how would you graph that line? Well, in order to graph that line, I would go ahead and have some graph paper here. And what I know is that this line is going to have some equation y is equal to m times x plus b. And the first thing that I would do is I would sketch that y-intercept. And so I would put a point on here where this line crosses the y-axis, and it crosses at 3 right here. So I'll put that point on, and then, well, I know that this line also has a slope of 2. Okay. So what does that mean, that it has a slope of 2? Well, it means that it's quite a steep ski hill. It's a ski hill about that steep. If I have shallower slopes, like slopes that are less than 1, they kind of look like this. If I have steeper slopes, like 2, well, then it's going to look like that. And so the first thing that I would do is put this point on and then sketch the line that has that slope. In order to get a second point, so I have here this point 0, 3, which is the y-intercept. I would go over 1 and up 2, up here to 1, 5. And then I could use a ruler between those 2 points to sketch that line. So there's the point 1, 5. Oh, it's really eluding me, but believe me, it's in there. There, 1, 5. Okay. So that's how you do that. And then you can practice sketching lines that have slope of 2 and y-intercept minus 4, slope of minus 3, y-intercept 4, etc. And to practice these, you can also check your work in Desmos. Here's a slope, let's choose the first one, slope of, let's do the second one, slope of 3 and y-intercept of 4, slope of minus 3. So if I have a slope of minus 3, here it is over here. It's very steeply diving downwards. And a y-intercept of minus 4, it's down there. So there's a slope of negative 3 and a y-intercept of minus 4. You can practice in Desmos, and you can also practice on graph paper. So m and b in this equation, they are the slope and the y-intercept. And that's just so key to remember. So can you take these lines and write them in y equals mx plus b form? And so practice all of these. When we're given a graph like this and asked to find the slope of the line and the y-intercept, to find the equation of the line, we really want to think about figuring out that m and that b. And this is going to help you with your guessing game that we'll play a couple times this week. So in this first example, first thing that I'm looking for is where does that line cross the y-axis? This one crosses the y-axis at 1. And then as x increases by 1, y is increasing by 2. So I know for this line here, b is 1 and m is 2. The slope is 2 and the y-intercept is 1. And I can also test that over here. And I can write that in. Y is equal to 2x plus 1. Oh, I said plus 2 plus 1. There we go. And then I can compare this red line here, which is crossing at 0, 1, and also has the point 1, 3. You see the points 1, 3 and around there. So let's take a look at that. Oh, there it is. Yeah, it's the same as this line. And so do the same thing for these lines. When we have a situation like this, what we're going to want to note is that m doesn't have to be an integer. This is the equation y is equal to 1 over 2x plus 0. We don't usually think about that plus 0, but there it is right there. It's crossing the line at y is equal to 0. And where do I get this 1/2? Well, if I go over, come on, zoom in for me. There. I get this 1 over 2 Because here, if I run for 2, I rise by 1. So this is plus 1 here, this is plus 2, and this triangle here, which is a right angle triangle, and we could use that to find, say, the length of from here to here. How long is that? Anyway, and you would use Pythagorean theorem. But anyway, this triangle gives you the rise and the run. And m is always equal to rise over run. And so in this case, m is equal to, the rise was 1 and the run was 2. So that's how I knew that this was a slope 1/2. Let's keep going. If we know that a line has a slope of 2/3 and a y-intercept of 4, how could you sketch a graph of that line? Well, this is how I would do it. I would first have my xy axis, so let's get a black color, go very thin. And so here is the x-axis, here is the y-axis, and I have a y-intercept of 4, so I know that I'm crossing up here at the point 0, 4, so I can label that. That's the point 0 in the x and 4 in the y. And that's where this line crosses. And it has a slope of 2/3. So if m is equal to 2 over 3, that's the same thing as saying this rises 2 when it runs 3. So I can go over 3 and up 2. Plus 2, plus 3. And that will give me another point. And then I have my line that goes through there, like so. So that's how you will do those. So try those with these ones here. And again, you can use Desmos to check your work. Let's take a look at a slope of 2/3 and a y-intercept of 4. So here, I'm going to turn on this one. I want a slope of 2/3. So let's put 2 over 3 for m and a y-intercept of 4. Oops, 4. So there it is. Crosses at 4. And then if I run over by 3, so this is running over by 3 and rising by 2. So that goes to the point 3,6. It's risen 2 from 4 and it's run 3 from 0. So that's how you would, and then once I have that point and that point, I can use a ruler to connect those 2 points and draw the line off to infinity in both directions. So absolutely, try many of these and then write the equations of each line and then check them in Desmos to check your work, to make sure that you're solid on this concept. Now, what about horizontal lines? What are we looking at when we have horizontal lines? Well, let's draw a horizontal line in Desmos. A horizontal line actually won't be of the form y is equal to mx plus b. It'll just be something like y is equal to 5. There. Horizontal line, y is 5 all along the length of this line. Notice x is changing, and y is always 5. Why doesn't this need an x in there? Lots of different ways to explain that. One of them is that I do have an x there. Y is equal to 0 times x plus 5. So 0 is the slope. It rises 0 as it runs whatever it wants. As it runs 1, it rises 0. So there is an x there, but it's being multiplied by 0. That's how I would explain it. You may want to find your own explanation. And then let's keep going. So for each of these lines, state the slope and the y-intercept, and then sketch it. So with some of them, they've been turned around. So be careful here. Negative 15 minus 5 over 6x. Well, this is a line that crosses the y-axis at negative 15 and has it runs 6 when it rises negative 5. So let's go ahead and graph that. This would be y is equal to negative 15 minus 5 over 6x. It's going to be way down here, crossing at negative 15. And then when it runs 6, it rises negative 5. So here is the point here, 6 in the x, negative 20 in the y. And that's a run of 6 and a rise of negative 5. So why was that so tricky? It's because they've given you the form y is equal to b plus mx. They turned the mx and the b and they shifted them, and it doesn't change the meaning when we write it in a different way. This one, for example, is written in the conventional way, where you have y is equal to negative 1/6 x plus 8. So this will have a slope of negative 1/6 and a y-intercept of 8. And so now we can use these same ideas to find the equations of these lines over here. So here, this one D, if we take a look at it, this is what we'd notice. Okay. So first thing that I'll notice is the B. And the B here is 4. And then what's our rise and our run? Well, if I run 2, I rise negative 4. This is negative 4 here, and this is plus 2 here. So this is y is equal to negative 2x plus 4. That negative 2 I get from rise over run, which is equal to negative 4 over positive 2, which is the same thing as saying negative 2. Okay, so there's my m, there's my m. This is the equation of that line. If we take a look at this one here, this one, I can find a point here, negative 8. So my b is equal to negative 8. And then I can use this point here to find my m. So this one, it rises 8 plus 8 when it runs 6. So rise over run here would be 8 over 6 is equal to m. And that's the same thing as saying 4 over 3. 8 over 6 is 4 over 3. I just removed the superfluous factor 2. So this one will be y is equal to 4 over 3 x minus 8. And then I can check that, of course, in decimals and make sure that the two lines are the same. Let's have a new line here. Y is equal to 4 over 3 x minus 8. If I come up here, I'll notice that I got this point correct, 0, negative 8, and I'll get that point correct, 6, 0. Okay? And so there's the point 6, 0, there's the point 0, negative 8, and so it connects those 2 points, so it's correct. Notice that this line looks a lot shallower slopey than this line, and that's because this scale is square. Notice that 2 in the x is the same size as 2 in the y, whereas over here the scale is not square. This is going down by 4, but this is going down by 2, so the changes are larger in y. That's why it's been flattened out by the scale. Yeah. So then we'll have interesting problems like, does the point negative 5, negative 20 lie on this line? And we want to be able to explain why. Well, we can do a couple of things. We could graph this line and then test and see if it does. Or we can also just check algebraically. So let's check algebraically. If this is the point xy, and we're interested in this point negative 5, negative 20, well, we can check and see if that lies on that line. Let's first check graphically. We know y is equal to 6x plus 10. So I'm going to get a fresh decimals here. Let's just go fresh decimals. So this is y is equal to 6x plus 10. So there's the line 6x plus 10. It's crossing up here at 10, and it has a slope of 6. And I was asked about this point here, 6x plus 10. I was asked about this point negative 5, negative 20. So let's go ahead and investigate what's happening at negative 5. And oh, it looks like this line is way down here. Let's see where it is. Oh, would you look at that? There's the point negative 5, negative 20. Happens to be on this line. And let's see why that is algebraically. What I can do is I can say, well, the point negative 5, negative 20 is a combination of x and y values. Let's input that there so that we would have y is equal to 6x plus 10. And so here we'll have negative 20 for y is equal to 6 times Negative 5 plus 10. Okay? 6 times negative 5, that's just bedmas. I just do that. That's negative 30. I still have the plus 10 there. And then I check. Negative 20 does indeed equal negative 30 plus 10. So because I get negative 20 equals negative 20, then I know when I get something true here, I know that this point does lie on that line. If I get something untrue, then it does not. Okay, so you can test those other ones. Now this is asking you to find an unknown x value c, so I'll leave that one as a thinking task for you. And this one, 3/4 n, and it is on that line, and we want to find the value of n. These are tricky. Let me know if you have questions. Come find me by email or meet me in class to ask. And then the part C questions, these I will leave to you as thinking problems. If you need the answers are all down here to test your answers. Any questions, absolutely come find me. Learn all this material before EQAO, and you will do very well with that test of your abilities. Bye for now, everyone. I hope your math practice is fruitful.